Hello everybody, I'm Dan. Welcome to my Java tutorial series. Throughout my tutorials I will teach you Java using just Notepad and the command prompt. The order in which my tutorials are organized on both my website at javacjava.com and my YouTube playlist is designed to maximize learning by building on concepts from prior tutorials. This tutorial is about overriding the equals method. I'm going to open up my web browser, my website, javacjava.com, and select begin. We'll scroll all the way down here to the bottom there, overriding equals tutorial. All right, now before watching this tutorial, I highly recommend watching my overriding the hashCode method tutorial, as it is important to understand what a hashCode is and how to override that method. The object class contains 11 methods. Over half of those methods are somehow dependent upon other methods within the object class to function properly. For example, in a previous tutorial, I discussed the relationship between the wait method and the notifyAll methods. One of the most widely used method, equals, shares a special relationship with the hashCode method. At this point, you should already be familiar with invoking the equals method on an object. Now, the purpose of this tutorial is to explain how to override the equals method. Consider the following statements, right? String x equals this string literal ABC, string y equals new string ABC, right? Passed in as a constructor. And then displaying to the console x and then invoking the double equal operator, right? That'll be false. And then x dot equals y, right? That'll return true. Now in the first statement, string x equals string literal ABC creates a new string in the string pool and assigns a reference to x. Now, if you're not familiar with the string pool, don't worry about it. It's not necessary for this tutorial. It's just being technical. Now, the second statement, string y equals new string, passing ABC string literal to the constructor, creates a new string in the heap and assigns a reference to y. Don't worry about that either there. Now, the third statement, equals the operator, which when used on an object returns whether one reference variable x points to the exact same object as another reference variable y. Now, they each refer to separate objects, so the return value is false on that. Now, by the way, you cannot override the double equal operator, just in case you were wondering. The fourth statement uses the overridden equals method of the string class to determine whether one object state, right, ABC, is equivalent to another object state, ABC. The two separate objects do indeed have the same state, so the result is true. Now, it is a little more complicated than that, though. Now, why would we want to override the inherited equals method from the object class? Well, that's an easy one. The equals method in the object class looks like this. Public, and then a Boolean return type equals the name of the method, obviously. And then for the parameter list, just a single parameter obj of object type, right? So basically, you can pass in any object in here. All right, and then in the method body, there's a single statement, return. And then basically, we're taking a look at whether this, being the current instance, is equal to basically the instance that you're passing, and the reference variable is pointing to that, right? And if it is, it'll return true, otherwise it'll return false. So by default, the equals method is simply mimicking the functionality of the equals operator. Now this method is just begging to be overridden into doing something useful. Now, the rules use big fancy words that you may be unfamiliar with. Don't let them intimidate you. Each one of them describe very simple concepts. Okay, the first one, it is reflexive. And don't pay too much attention to these rules, because I'm going to go through them in detail here. But I'll just whip right through them reading them here. So it is reflexive. For any non-null reference value x equals x should return true. It is symmetric. For any non-null value references x and y, x equals y should return true if and only if y equals x returns true. Okay? It is transitive. For any non-null reference values x, y, and z, if x equals y returns true and y equals z returns true, then x equals z should return true. It is consistent. For any non-null reference values x and y, multiple invocations of x equals y consistently return true or consistently return false, provided no information used in equals comparisons on the object is modified. For any non-null value x equals null should return false. Okay? Now, so far, you're probably like, holy cow, well, I don't have no idea what they're talking about. And if you're not familiar with this, you really shouldn't. Don't worry about it. This is all going to make sense. I just kind of want to plant these seeds in your head here, in the back of your mind there. So when I do actually go into the concepts and explain them in detail, you're like, oh, okay, I get that. That's sweet. Now, this last one here is not necessarily a rule, but I put it in there. If we come over here to the object class documentation here, right, and then we click on the, where are you? Equals, here we go. This is taken verbatim from the website there, right, on these first 5. Now this line right here is, I'm including it as a rule too as well, and that's because it really should be a rule, and in my opinion anyway, but note, it is generally necessary to override the hashCode method whenever equals is overridden so as to maintain the general contract for the hashCode method, which states that equal objects must have equal hashcodes, and this will play into importance and towards the end there. All right, so you will learn properly overriding the equals method is no trivial task. Now let's jump right in and have some fun. Let's come down here and highlight all the source code. Don't be intimidated by the amount of source code. It really doesn't add up to a whole lot. I've just got a lot of different steps where I'll be removing stuff and uncommenting stuff in there. So Control-C to copy or right-click and select copy. Let's move the browser off screen. I've got a shortcut to the command prompt on my desktop, but if you don't, you create one really fast by right-clicking, selecting New Shortcut, CMD next, and Finish. It's just that easy. Let's go and open this up. If you're new to my tutorial series, first thing you want to do when you open this up is type in Java-C, which is the Java compiler command. You should see all this stuff scroll by. However, if you receive an error message, watch my tutorial on installing the Java Development Kit. You want to make sure you get that installed and configured properly before continuing. CLS to clear the screen, CD space / CD is short for change directory / tells it to go to the root. I'm going to make a directory here called Java with the MD command. I already have that folder, but if you don't, I'll create one for you. I'm going to make another directory here called overriding equals. All right, change directories to the overriding equals folder, and I'm going to notepad overriding equals.java. Okay, name of my source code file, also known as a compilation unit. Let's go ahead and paste this stuff in here, and there's a lot of stuff in here, but don't worry about it. It'll all break down into little steps that you can understand really easily. So the first thing that I want to talk about is this little class called inster, right? And inster is just, me being creative or silly depending on how you look at it. But anyway, that's the name of the class inster, and it has its state is represented as a primitive int value called state. I've got this constructor right here where the parameter for the constructor is an int value, obviously there, and I'm setting the current state equal to the state parameter of the constructor. Very simple getter method here, get state, returning int type back that just simply returns our state. Okay, so that's all there is to the inster class there. Let's come back up here to the overriding equals method where I got the main method entry point. So I'm creating 2 inster reference variables, x and y, and I'm setting x equal to a new inster object, and I'm passing in 41. So the state on this particular inster object will be 41, and then a new inster object for that the y will point to with 41 also. Okay. Now pay no attention to all this commented stuff down here. We'll get to that fairly quick. Now the next statement that I'm going to execute is basically x equals. And then I'm going to invoke the getState method, right? Which will simply return back our current state, which is 41. And then I'm going to display the x hashCode equals and then just invoke the hashCode method. Now the hashCode method is basically the one that it inherits from the object class, and it displays that to the console. And then I'm going to display the state of y and the hashCode for y, and then just a blank line. Now after we display that, I'm going to display the return of x and then the equals operator is y, right? So return that back that, and then x, and then invoking the equals method on the x object there, right? And passing it in the y object references technically, right? So and then display a new line to the console. So let's come up here and save this and see what we get, right? So all in all, not too difficult there. Let's Java-C. Let's compile that. Java to run it. We get x, the state equals 41, the hashCode equals this. Y, 41, the hashCode equals that. Does x and then double equal operator y, is x equal to y? No, that's false because the x points at a separate object, y points to a separate object, so they're not the same. Now x dot equals y, x invoking the equals method and passing in y, that returns back false too as well. And ultimately in this tutorial, we want this to return back true, and we want to do it properly too as well. So coming back here to the tutorial, you remember that I said this is the declaration for the equals method right here, right? And it's pretty simple. So you could see, the current state, this, right? Which is x, of course. Does it equals the object, right? No, it doesn't. So we need to overwrite that so that it's equivalent, right? So that the value of the x object is equivalent to the value of the y. We want to say that's true. Is 41 equivalent to 41? Yes, it is. Let's return true on that. All right, now we're ready to come down here and get into some interesting stuff. So what I've got is inster here. I'm going to get rid of this one here. And I've got basically this same inster class here with a lot of stuff commented out. And a lot of those stuff is just basically all the steps that we're going to be going into it there. All right. So at this point, it's identical to the class I just deleted out of there, right? And here I'll show you, boom, and redo it, right? And so we get the same exact results, same hash code, same everything there. All right, so let's start off by duplicating the equals method from the object class. And let's go ahead and just uncomment the override. So I got the add override annotation, and then the public Boolean equals, passing in an object, reference variable obj of object type, and we're returning whether this being, the current instance of inster, right, is equal to the one being passed in, right? So we're going to get the exact same result here, right? We compile that, right? And we're getting false and false. So far we've got it all set up just like it is, like a normal inheritance there. All right, so let's step 2. Step 2 is to modify the return statement with the following if statement. So what's the first thing we want to check for? Well, what if, for example, we were dealing with the same object, right? So let's just come up here and let's do this. Let's say, for example, let's set x equal to a new inster object there, and then we'll set y equal to x. Y and x are pointing at the same object. Well, if that's the case, we don't want to go through a whole bunch of tests, right? Only to return true. So if both references are referred to the same object, hey, easy peasy, we return true, and then we get out of here. Otherwise, we return false. Okay, so let's uncomment step 2 with overriding the equals method, and let's get rid of the step 1 override there, okay? All right, so let's come up here and save this. Let's clear our screen, let's recompile, let's rerun, and we get true, right? You can see state is 41, or hash code's this, state is 41, or hash code's that. X and Y, does X the equal operator, Y, equal true? Yeah, they're pointing to the same objects. So yeah, they are going to return back. Everything is good about the contracts. Just trust me on that for right now. Both the hash code contract and the other. Well, that's all we have to do in order to satisfy that condition there. All right, so let's now come back up here and undo this. Oh wait, hold on, we want to do new inster 41, right? Okay, and so I undid step 1. Let's talk about step 3. Now, step 3 is to check to see if we are dealing with an object that is an instance of, and I should actually have this instance of right there, instance of inster, right? And so let's go ahead and show you that we've got this same if statement up here. We got our same return false down here, and now we're just checking to see if the object being passed in reference is an instance of inster, right? If it is, we'll go ahead and return true, but we're not done yet. But we're primarily looking to say if it's not an instance of inster, there's no way, it can be equal. So let's go ahead and return false. So let's get rid of step 2, and let's bring step 3 up here. And let's check this out right there. Let's come up here, and I've got something going on with this next line that I'm uncomment. So I got string builder SB equals new string builder passing in string literal ABC to create a new string builder object. It's totally ridiculous that we're checking a comparison on this, but you want to account for stuff that isn't an instance, and you don't want it to crash your program out at runtime either. So let's see x, if we invoke the equals method and pass it the SB reference to the string builder object, let's see what happens here on this, right? Okay, so let's clear our screen and then I'll run it. Okay, x dot equals SB comes back false. So we didn't get any error messages or anything like that, right? So that is cool. We can account for that. And I'm just going to go ahead and get rid of that just to clean this up a little bit as we go. And now we're ready to talk about step 4. Now, step 4, we are now ready to see if the state of the object parameter matches the state of the current object. All right, we're getting rid of step 3. We're going to bring step 4 up here. So inside of the instance of, right? So if it passes that test, now we want to see if this.state equals the object and invoke the getState method on that. Now, because this is an object type obj for the reference variable here, object does not have the getState method in here, so we have to downcast it to an inster object type, right? So if this syntax doesn't make any sense, watch my tutorial on casting and downcasting, upcasting, all kinds of casting there. But we do have to cast that down, because if we just try to do object.getState, right, without that in there, it'll say it can't find this method, right? Because object class does not contain that method. So that should make sense there. So downcast that. So if the states are the same, 41 is equivalent to 41, right? Because we're comparing primitive int types. We're going to go ahead and return true. All right. So, and that should be like, all right, yay, all right, we should be done, but we're not. So let's come up here and save this. Let's clear our screen. Recompile, rerun. So we've got still our state 41, different hash codes. They're different objects, but now they're equal, true. All right, great, we're getting somewhere. So let's talk about the last thing that we need to do, and that's we cannot forget to override the hashCode method to ensure the hash codes match. All right, I'm gonna go ahead and get rid of this here, bring this up here, and display this. I'm going to save this here. And basically what we need to do now is we need to check to make sure the hash code is equal to the hash code being passed in. Now, why do we need to do this? And I'll tell you why. Because at that point, after step 4, we broke the contract for the hash code here. So I'm going to pop open here. I've got this. I've got my website open here. I'm going to click on the override hash code method. I'm going to come down to the rules here. Now, if you watch this, which you should have there, right? We need to talk about this rule right here, this contract for the hash code. So if two objects are equal according to the equals method, then calling the hashCode method on each of the two objects must produce the same integer result. As you can see, it's not. The hashCode here is this producing, the one starting out with 7, this one's producing 3. Okay, so we need to override the hashCode method by doing this here at the add override annotation, then public int hashCode. And basically, I'll keep it simple for this tutorial. If you do not understand what is going on below, you need to watch my tutorial. You need to watch and understand my hashCode override tutorial. Basically, I'm going to return state times 1. Okay, now we know hashCode is an int state, right? And we know that hashCode needs to be the same based on whatever, the state is for whatever complicated algorithm we've got going here, which is state times 1. A real complicated algorithm there, right? But anyway, so we know that the state will always be the same if the objects are equivalent, right, for our equals thing there. All right, okay, so let's go ahead and then we're going to check that right here, right? If this .hashCode equals obj.hashCode, right, then return true, we are done. Let's come up here and save this. Let's clear our screen, let's compile this, and let's run it. So you can see our current state of x is 41. Our hashCode is now equal to 41. Current state of y, 41. Our hashCode is now equal to 41. X and then the double equal operator y, that's false. We're still looking at two different objects, right? But now x and then invoking the equals method passing in y returns true. And we basically have determined that the state of x is equivalent to the state of y, which is exactly what we wanted to do. That's ultimately what we were looking to do. Now, are we done yet? The answer is no. We need to run some tests on it to make sure that these rules that I went over for the object class actually match. So bringing back over this here, right? We've got all of this stuff right here. It is reflexive. Now this is smaller font, so I'm just going to bring it up in my website where I've got the whole thing cut and pasted basically verbatim. So it is reflexive for any non-null reference value x. What does this mean right here? Well, basically that means that we don't want this, right? So if x is equal to null, we can't invoke any methods on it, right? Because we're just going to get a null pointer exception, right? So that statement right there, that portion of this says for any non-null reference value x, x equals x should return true, okay? So I'm going to uncomment this down here. I'm going to say the string little reflexive equals and then x equals x. So we're going to run the exact, basically this right here, right? Okay. All right, so let's come up here and let's save this, clear our screen, recompile, rerun, and we got reflexive equals true. All right, 1 out of 6 done. So now it is symmetric. For any non-null reference values x and y, x equals y should return true if and only if x equals, or y equals x returns true. Let's come back over here to the source code here. It's exactly what I've got going on the next one. Symmetric equals, and then I'm checking for x equals y, and then and, that's obviously the short circuit and operator there. So both of these have to equal true. If one of them equals false, it's going to return back false. Or if both of them return false, it'll return back false. But anyway, so symmetric. Let's go ahead and compile that. Let's clear our screen. Boom, boom, boom. Symmetric equals true. All right, 2 out of 6. Let's talk about the next one there. It is transitive. For any non-null references value x, y, and z, if x equals y returns true and y equals z returns true, then x equals z should return true. Okay, so for this next test, we have to introduce a new instance of the inster there, and there'll be z, setting that equal to 41, right? And then there's our transitive there. X equals y, y equals z, exactly what they said, and x should equal to z if. So all three of these are true, especially if this is true and that's true, then this should be true, right? Let's go ahead and save that. And let's clear our screen. Run that. So transitive true. All right, we're 3 out of 6. Getting closer to being done here. So it is consistent. For any non-null value references x and y, multiple invocations of x equals y consistently return true or consistently return false, provided no information used in the equals comparison on the objects is modified, right? You don't want to modify state and, and see different invocations, but multiple invocations without modifying the state should either always return true or always return false. All right, so on the next line here, what I'm going to do is I got this simple little for statement there, exactly what they say. So I'm just looping 5 times and invoking invoking the equals method on x and then passing it y, and we should get the same value every time. Let's clear our screen. Okay, so consistent, 5 times through, true, 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 true. All right, excellent. We're good to go on that. All right, the next one is super duper easy. For any non-null reference x equals null should return false. Okay, so very simple there. We'll run that little test there. So x equals null, and let's see what that comes back with. Let's save that, clear our screen, recompile, rerun. Okay, null equals false. All right, now we're down to our last one here. Last one, which by documentation considered it optional, but I really don't think it's optional there. So our last little test is just to make sure that the hashCode method for the current instance matches the hashCode method of the instance being passed in. So we'll uncomment this and display the hashCode test, and then plus the result of hashCode, x.hashCode, and check to make sure that's equal to y.hashCode. And remember, hashCode returns back a primitive int type, so the double equal operator will just return true if 41 equals 41 in this particular case. Okay, let's clear our screen. Let's run this. So hashCode test, true. All right, so that pretty much does it there. I'm going to go ahead and get rid of this and get that off screen there and leave you guys with some final thoughts. By now, you should understand that overriding the equals method should not be done carelessly. Skipping or not understanding a single step can really come back to create some nasty bugs at runtime. If you understood why each step is necessary, then congratulations. However, if you are unsure about anything, watch the overriding hashCode tutorial and then this tutorial again. That concludes this tutorial. Thanks for watching.